Experiment 3. Aim. To perform and observe the following reactions and classify them into A. Combination reaction. B. Decomposition reaction. C. Displacement reaction. D. Double displacement reaction. 1. Action of water on quicklime. 2. Action of heat on ferrous sulfate crystals. 3. Iron nails kept in copper sulfate solution. 4. Reaction between sodium sulfate and barium chloride solutions. Materials required: 4 test tubes, a beaker, test tube holder, tongs, test tube stand, a dropper, a piece of sandpaper, Bunsen burner, a small piece of quicklime, ferrous sulfate crystals, iron nails, clean and unrusted, copper sulfate solution, aqueous sodium sulfate solution, barium chloride solution, distilled water, dilute sulfuric acid solution. Theory. 1. Action of water on quicklime, combination reaction. Quicklime is also called calcium oxide, CaO. It combines with water to give calcium hydroxide, CaOH, also known as slaked lime. CaO in solid state plus H2O in liquid state results in CaO2 in aqueous state with heat. In the above reaction, two substances are combined to form one product, hence it is called combination reaction. Heat is released in the reaction, so it is an exothermic reaction. Slaked lime solution changes red litmus blue, so it is basic in nature. The freshly prepared slaked lime is also known as lime water. It becomes milky when carbon dioxide gas is passed through it. 2. Action of heat on ferrous sulfate crystals, decomposition reaction. Ferrous sulfate crystals are light green in color. The color is due to the presence of water of crystallization. On heating the crystals of ferrous sulfate, it undergoes the following changes. 2 FeSO 4.7 H2O in solid state. Ferrous sulfate, light green color, results in Fe2O3 in solid state. Ferric oxide, brown color, plus SO2 in gaseous state. Sulfur dioxide, colorless, plus SO3 in gaseous state. Sulfur trioxide, colorless, plus 14 H2O in liquid state. Water. The color turns to brown due to the formation of Fe2O3, SO2 and SO3 gases are released. Water of crystallization is released by the crystals. Single compound decomposes to form 3 new compounds, hence it is a decomposition reaction. SO2 and SO3 gases changes moist blue litmus paper into red, hence it is acidic in nature. SO2 shows reducing property. It turns the orange color of acidified potassium dichromate to green when it is allowed to pass through the acidified potassium dichromate solution. SO2 gas has a choking smell. Do not inhale the gas. Keep the mouth of the test tube away from your face. SO2, in the presence of water, sulfur dioxide is able to decolorize substances. It is also used for bleaching papers and delicate materials such as clothes. Oxygen in the atmosphere reoxidizes the reduced dyes, restoring the color. SO3, sulfur trioxide, causes serious burns on both inhalation and ingestion, since it is highly corrosive in nature. SO3 should be handled very carefully as it reacts with water violently and produces highly corrosive sulfuric acid. Iron nails kept in copper sulfate solution, displacement reaction. Fe in solid state. Iron, gray color. Plus CuSO4 in aqueous state. Copper sulfate, blue color. Results in FeSO4 in aqueous state. Ferrous sulfate, light green color. Plus Cu in solid state. Reddish brown color. Iron nails when dropped in blue-colored solution of copper sulfate it exhibits following changes. A. The blue color solution turns green, hence it is known as a displacement reaction into light green color. B. Fe2 plus ions replace Cu2 plus ions and make iron sulfate in the solution. C. Iron nail gets the deposit of reddish-brown copper metal on it. D. Fe atom forms Fe2 plus ions by loss of electrons and undergoes oxidation, and Cu2 plus ions by gain of electrons becomes Cu atom and undergoes reduction. 4. Reaction between sodium sulfate and barium chloride solutions, double displacement reaction. Na2SO4 in aqueous state. Sodium sulfate. Plus BaCl2 in aqueous state. Barium chloride. Results in BaSO4 in solid state. Barium sulfate, white PPT. Plus 2 NaCl in aqueous state. Sodium chloride. Sodium sulfate solution and barium chloride solution are colorless. Mixing of both the solution provides white-colored precipitate due to the formation of barium sulfate. The exchange of metal ions takes place in the reaction and is known as double displacement reaction. Barium sulfate is insoluble in water and forms a precipitate. Procedure. Experiment. 1. Combination reaction. Take a clean beaker, put a small piece of lime in it, and add water drop by drop into the beaker. Observation. Reaction takes place with crackling sound and steamy vapors are released. The beaker becomes hot. Inference. An exothermic and combination reaction take place. Reaction. CaO in solid state plus H2O in liquid state results in CaOH2 in aqueous state with heat. 2. Decomposition reaction. Take a clean and dry test tube, add few crystals of ferrous sulfate. Fix it on a test tube holder. Heat the test tube on burner. Put the mouth of test tube away from your face. Waft the gas release to smell and test it with acidified potassium dichromate paper. Observation. The green crystals turn reddish, brown, tiny droplets of water are settled near the neck of the test tube, and a colorless gas with choking smell is produced. The acidified potassium dichromate paper turns its color from orange to green when held in the gas. Inference. Iron sulfate, green, crystals decomposes due to heat. Water of crystallization is collected in the test tube. Turning potassium dichromate paper green exhibits SO2 gas. It is a decomposition reaction. Reaction. 2FeSO4. 7H2O in solid state. Ferrous sulfate, light green color. Results in Fe2O3 in solid state. Ferric oxide, brown color. Plus SO2 in gaseous state. Sulfur dioxide, colorless. Plus SO3 in gaseous state. Sulfur trioxide, colorless. Plus 14H2O in liquid state. Water. K to Cr2O7 in aqueous state. Plus H2SO4 in aqueous state. Plus 3SO2 in gaseous state. Results in Cr2SO4, 3 in aqueous state. Chromium sulfate. Plus K2SO4 in aqueous state. Plus H2O in liquid state. 3. Displacement reaction. Take a clean test tube. Add 2 to 3 milliliters of copper sulfate solution in it. Keep an iron nail cleaned with sandpaper in it. Place it on the test tube stand and see the changes for about 30 minutes. Observation. The blue color of copper sulfate slowly fades away. The iron nail gets the deposit of reddish-brown color. The blue color of solution turns to green. Inference. Iron metal is more reactive than copper, so displaces it to form iron sulfate solution. It is a displacement reaction and reddish-brown deposit of copper is formed on the iron nail. Reaction. CuSO4 in aqueous state. Blue color. Plus Fe in solid state. Gray. Results in FeSO4 in aqueous state. Light green. Plus Cu in solid state. Reddish brown. 4. Double displacement reaction. In a clean test tube, take sodium sulfate solution. To this, add barium chloride solution. Shake the contents and observe. Observation. Both sodium sulfate and barium chloride solutions are colorless. On mixing together, a white precipitate is formed. Inference. The white insoluble precipitate of barium sulfate is formed. It is a double displacement reaction. Reaction. Na2SO4 in aqueous state. Colorless. Plus BaCl2 in aqueous state. Colorless. Results in BaSO4 in solid state. Barium sulfate, white PPT. Plus 2 NaCl in aqueous state. Sodium chloride. Precautionary measures. 1. Use tongs and do not touch quicklime with hands. 2. Mixing of quicklime and water releases large amount of heat, so add water drop by drop and use borosill beaker. 3. For heating, use hard glass tubes. 4. Never inhale any gas, just waft the gas. 5. Avoid to touch any chemical with bare hands. 6. Have the mouth of the test tube away from your face while heating. 7. The iron nails must be cleansed properly by using sandpaper before dipping them in copper sulfate solution.